Good evening, students. This topic is related to pushdown automata. I received some of the answers from the students. The answers were not appropriate, so I thought to explain a few more problems related to this concept. Okay, so I'll just review the concepts related to pushdown automata. I hope you have understood the basic concepts of this through the videos which I have posted. So let's have a review of this topic and then we'll go for the problems. So coming to the pushdown automata, it is introduced to overcome the drawback which is present in finite automata. As you all know, we have discussed in the finite automata, we pass any string which is from length 0 to infinity, and whenever it is asked to just accept the string, finite automata does it well. But whenever there is a string where you need to compare, like a language is given like a power n, b power n, and if it is given like n greater than or equal to 0 up to some extent of n, that is like a power 5 or b power 5 or a power 100, b power 100, wherever you have n is given as countable, where when n is given as some specific number, finite automata will accept this and it will pass this string through the input tape, where it reads each and every symbol, it justifies, it cross checks with this language and it passes. But when here in this example, it is not enough to give the number of the number to the n. Here we also need to check whether equal number of a's and b's are there. So we need to have a power n, b power n, we need to cross check how many a's are there and how many b's are there. This comparison cannot be done in the finite automata, and why it is not done is, in order to cross check number of b's and number of a's, first of all the finite automata should remember how many a's are there, then only it can cross check with the b. If it is a finite number like a power 100, b power 100 also it can remember, but when the string is going on extending, that many number of a's it cannot remember and it cannot compare with b, because the drawback in finite automata is limited memory. So in order to overcome this, to the existing finite automata only we are adding a new memory which is called as PDA store or PDA stack. Okay, we are not introducing a new concept. To the existing finite automata we are adding an extra memory. Okay, so hence it behaves in a similar way as finite automata, except that we have some operations which are an additional operation in the PDA. So this is called as a PDA store or PDA stack, and we have an input tape and we have a read write head which will read each symbol at a time whenever a string is given. This is already done in finite automata. So to this we are adding a memory. This is called as PDA store or PDA stack, which is represented using this tau symbol. And in this PDA store we have a default symbol Z0. In some books they use X or Y or any symbol. Okay, here we use Z0. Any symbol can be used by default. Here we use Z0. And the tuples which it uses is it uses the same tuples as that of finite automata, and it uses two additional tuples, that is Z0, the default symbol in this stack, and tau, which is representation of this stack. This total stack representation is called as tau. Okay, so if you see the tuples or the things which are required for the working of the PDA, we have capital Q, that is the number of states, sigma input symbols, delta is transition function, Q0 initial state, and F is final state. So these 5 are already included in the input tape. Additionally we are including two things, that is Z0, the default symbol in the stack, and tau symbol, which is the representation of the total stack. Okay, so all these are same as that of the finite automata, and one more change which we are doing here is transition function, that is delta. In finite automata we have only the states and the sigma, and the sigma can include the epsilon or cannot include the epsilon. It may sometimes it may include only alphabets. So here in this PDA there are some operations which use epsilon as one of the input symbol. So the transition here it includes states and sigma, which also includes epsilon, into the tau representation. That means we are including z0 also. Z0 will also be used in the transition function. This tau represents that there are some operations which are being using z0. So we are using for this purpose we are using this tau symbol. So this is the total transition function. And coming to the operations in the stack, we are having three types: push, pop and read. These are the major operations in the PDA. These are the same operations which you use in your data structures. You have push operation, pop operation, and this is an additional operation that is called as read. All these three things we will use based upon the problem. Now PDA it allows infinite strings along with comparisons here. Okay, so here this is a tape, input tape. Some string is given to us. It may be some input string is there and it is asked to check whether this can be passed through PDA or not. So we have a stack symbol here. By default we have Z0 is a stack symbol. First we will try to push the symbol. Push the starting symbol from the input tape first onto this stack where Z0 is already there in the topmost symbol. So first push A onto the Z0. So when you push, this Z0 will go down. Okay, and this operation we will represent it using A is the input tape. Always write the first symbol as the input tape symbol which you are taking, comma, the next input will be the topmost symbol in the stack. The topmost symbol here is Z0. So we are writing it as A Z0, and the output which you are getting after pushing this A over Z0 is A Z0. Z0 will go down whenever you push an element on top of the stack. So after this A will be removed from the input and it will be passed on to this. So this A will no more be there in the input tape. So the resultant will be X, B and Y. After doing this, if you want to do one more push operation, then you have to go for the second element in the stack from this direction. You have X, B, Y. So then X has to be pushed onto the stack. Already A and Z0 are there in the stack. So upon A, X will come. So first you have to write what symbol from the input tape you are taking, that is your first input, comma, what is the topmost element on the stack, that is X. So then you push, and what is the resultant, what is the push operation or what is the change that has happened in the stack, that you have to show, that is our output. So that is XA. And remember that in push operation, whenever you do some push operation, you have to show only the first top two elements. See, this is input 1, input 2 and this is XA. This is the output. Whenever you find two symbols as output, two symbols as the output here, this represent push operation. Okay, so here only two symbols are there, we are showing only A Z0 as our output. Here already three symbols are there, no need to show all the three symbols, you have to show only the topmost two symbols. So hence we are showing only XA. So this is related to the push operation. Now next one is pop operation. Pop in the sense you have to remove the element one by one, and since this is a stack, you need to remove from the topmost element. So suppose we have some string by input, this is the input tape. Now I want to remove one of the element from the stack. This is the elements that are present in the stack. So you cannot remove without any condition. For pop operation always there should be some condition. So the condition here what we are taking is, whenever a B is there and whenever corresponding X is there, then only pop the element. Pop the element in the sense you are removing an element from B, from this input tape B, and correspondingly you are also removing the topmost element in the stack. That means you have to delete B as well as X. So the always write the input tape symbol first, that is B you want to you have to compare, the condition is with respect to B. So B comma the element which is present on the topmost symbol as on the stack is X. Remove this X. So the resultant status of the stack should be shown. So when you remove X, this cell is empty. This empty cell is always shown are always represented using this epsilon. So we have b comma x slash epsilon. After slash, whatever you write is our output. So when you remove b and x, in the stack x is removed, in the input tape b is removed. So resultant is y. This is our pop operation. Then still, if you want to remove y, you want to make this as empty, this total input, then also there should be some condition given to us. If y is there and let us assume whenever y is there in the input and correspondingly on the top of the stack if there is element a, then for each y and for each a remove these two things. So remove y from the input tape, remove a from the stack, then this cell will be empty, and as soon as you remove an element above z0 will come up. So z0 will be on the top and this empty cell is represented by epsilon. So the transitions or this operation you are representing using input tape y comma a, and the output always represents only the status of the stack. You are not supposed to show the status of the input tape as output. Always you have to show the output is output as the status of the stack. Okay. So after removing a, this particular cell is epsilon. After it becomes epsilon only z0 comes up. Okay. So this step is after you write epsilon, then only z0 will come up. So don't write here z0, you have to just write epsilon. Okay. And the third operation is read operation. Read operation is when you don't want to push or pop anything. If you just want to read whatever is there in the input tape or on the stack, then we use this read operation. So here we have the some symbols in the input tape and some symbols in the stack. You don't want to make any change in the stack, then what we do is we simply keep the elements which is present in input tape and which is present in the stack as it is. So there is no change, and that transition we will write it as input tape symbol, that is x, and the input tape input symbol on the stack as a, and the status, the output is the status of the stack. The status in the stack is same as it is before. So we just write it as a only, there is no change. And see here, if you observe these three operations, after slash indicates the output. If you find two symbols, this means it is a push operation. If you find only epsilon, it indicates it is a pop operation. And if you find the same symbol as that of the stack symbol, this is input, this is output. If these two are same, it means it is only read operation. You have not done any push or pop operation. So in this way you have to represent the three operations